Hey everybody, welcome back to Young Engineers of Today. I hope you had a good couple of days, and I hope you're all ready to continue with CNC machines and Fusion 360, although it's going to be predominantly Fusion 360 over the next few lessons. Um, this is probably going to take us a while to get through the build, this entire build, just because there's a lot going on, and it teaches you a few different techniques that you can use. So it's not necessarily going to be entirely straightforward the entire time, although there are going to be some parts which are going to be faster than others. And there is going to be a little bit of a learning curve associated with getting used to the interface and things like that. So, I mean, it's to be expected, and that's okay. It'll take a little bit longer, but we'll get through it. We'll have a bookcase at the end. You'll know how to make it, how to sort of turn it into something that you can construct in real life and print it out or cut it out on a CNC machine. It'll all be pretty cool, hopefully. Um, but that is the plan for the next, who knows how long. I guess as long as this takes. Um, but yeah, like I said, I hope you guys had a good couple of days. Hope you're ready to learn some more. And we're just going to start this off with a little bit of a review like I normally do. So Monday was spent pretty much just talking about CNC machines. What they are, how they work, what you would need, so on and so forth. We spent a little bit of time getting Fusion 360 downloaded for you guys so that it would be ready for today. If you have any questions about that, obviously, just let me know. But once we get through the review, I'll spend the time, getting you guys doing at least the initial setup on Fusion 360 so that you can start working on it. So yeah, CNC, what is it? It stands for Computer Numerical Control. Like we said, CNC machine could be a whole bunch of different stuff. The CNC comes in when it's computer controlled and not human controlled. As opposed to like a lathe that you might use in a machine shop. That would be human controlled. But there can be CNC lathes. Most of your input for that reason is going to come through CAD programs in generating the actual initial design, although there is some stuff you can do in CAM programs. Interesting. Okay. There is some stuff you can do in CAM programs, which will allow you to change sort of how the model is going to cut out the, or how the machine is going to cut out the model from the stock. So it can be, either a faster cut or more precise. You do it to ensure that you don't accidentally cut off any pieces of your model or anything like that. Just various things. And then, of course, there's the machine controller, which are drivers, and eventually, control the machine, send the instructions to it so that it can cut out whatever you've set up to cut out. We talked about the different kinds of CAD software. There's more freeform and artistic software. There's some software that lies kind of in the middle, and then there's the very engineering-based and professional grade software, which Fusion can count itself among. So, if you guys get familiar with this, you should be pretty well prepared for a lot of other technical CAD programs that might be thrown your way, like SolidWorks, for instance. SolidWorks is actually, I won't say very similar, but it's similar enough to Fusion that you would have a much easier time figuring your way around everything. And then we talked about CAM software, different types of CAM software. Mostly just has to do with manufacturers or who they work with or who they don't work with or whatever, what they can do, things like that. And then machine controllers, well, again, like drivers, they can be operating system specific, they can be brand specific, or they can be more generalized. Can we make that a little bit larger? I don't know why that's 18. There we go. Perfect. So we said, or I said, thankfully that most software has at least a couple of these steps integrated into it. So for instance, Fusion that we're going to be working with is cat is lying down on a bag that has more bags inside of it and is just making so much noise. I'm sorry if you can hear that. Um, Most of these have a couple of steps integrated directly into them. So for instance, Fusion 360 is CAD software, although it can function as CAM software as well. There is a CAM portion of the program that you can then use to get it set up for a CNC machine. So it kind of serves double duty in that case. Once we get far enough with the building of the bookcase, we'll probably spend some time experimenting with the CAM part of Fusion 360 so that you guys can get familiar with that as well for your lab portion. We talked about the different types of cutters, just a couple of different examples. It needs graphics here. Of course, cutters will serve different purposes based on their shape and things like that. You might need one in order to get a cut started. You might need another one in order to shave things off the side. You might need another one in order to get more of a tapered kind of a cut on something without rotating everything. It all depends on the tool you have and the purpose you want to use it for. And then we talked about some of the properties that you can affect in a CNC machine, specifically speeds and feed rate. Speed being the rotational cutter of the rotational speed of the cutter in revolutions per minute, and feed rate being the speed that the cutter is moving through the stock. And there isn't really a set in stone value for either of these, so it's not like I can tell you right now, oh hey, set the speed to 600 RPMs and the feed rate to an inch per minute, which would be really whatever. Anyway, examples. Can't really do that because it's going to change based on the job, based on what you're using, all that kind of stuff. So for that reason, you want to generally look at the recommended settings on on another mill or a shopbot or whatever kind of CNC machine you're using, and sort of fiddle with it from there. Say, oh, well, maybe I want it to be a little bit more precise, so I'll have it go a little bit slower, that kind of a thing. It matters, though, because you want to make sure that you don't break any of your cutters, and you want to keep it as accurate and precise as possible, so that you generally have a nice-looking model. And then we talked about the kinds of materials that it can use. We actually talked about a decent amount on Monday. Use metals, plastics, wax, foam, wood, medium density fiberboard, which is if I remember correctly, it's a type of compressed wood. Anyway, just a whole bunch of different stuff. And then we went over the process for getting it downloaded from Fusion 360's site. So we spent a little bit of time getting that downloaded, started for you guys. So hopefully that should be downloaded. Raise your hand if you've got it all ready to go on your computer. You just haven't started it up yet. Or maybe you have. Who knows? Okay, a few hands. Raise your hand if it still needs to be downloaded or installed in some fashion. No hands. Okay, good. And that's fine, even if it did, it's good to know now so that we can get you on the right track. But excellent. Glad to hear it. So let's go ahead and open up Fusion 360. Where is it hiding? There it is. And Fusion 360 is a decently memory intensive program, so it can be a little bit slow to start up the first time, especially if there's something to download. So, be patient. Give it maybe a minute or so to do its thing. However, you should probably be confronted with a sign-in screen, if I'm not mistaken. It might look something like this. If you already have an account, that's excellent. Just go ahead and enter in your email address or your username and your password. If you don't, you can sign up. And of course, that requires some personal information. Now, Autodesk is generally a name you can more or less trust, so you don't necessarily have to worry too much about what kind of information you're putting in there. So you can put your information in there. That's okay. First name, last name, give it an email address, and then set up a password, and then make sure to agree to the terms of service, the second checkbox. You can keep the first checkbox unchecked because all it does is it just sends you emails about promotions and stuff like that. Once that's done, you might have to, open up a verification email or something like that from Autodesk. It's possible. Or you might just be taken to the new sketch screen, something like this. Raise your hand if you've got something that looks like this now, or once you've got something that looks like this now. Cool. Few hands already. Excellent. Alright, just wait on a couple more hands and then we'll keep going. But those of you who are here already, welcome to Fusion 360. This is what you're going to be staring at a lot. It's just going to have stuff on top of this. Okay, I'll spend some time going over the different controls and stuff like that, and then we'll go from there. So, like I was saying last time, there are a few different sort of movement controls that you need to get yourself familiar with in order to be, really effective at using this program. The first and most obvious one is using the mouse wheel to zoom. However, it is reversed from what you would expect. What is normally zoom out is zoom in, and what is normally zoom in is zoom out. So that can take a little bit of getting used to, but it's not like it's earth-shattering, life-changing, or anything like that. It's just going to take some getting used to. Next, you're going to need to be able to pan it, which you can do by clicking in the mouse wheel, which also has the lovely sort of unintended consequence of causing it to zoom, at least on my computer. Your computer might be different, but my computer, it certainly does that. Not really life-ending. You can always just zoom in after you pan to where you want to go. And then you've got the ability to rotate. Rotating is important because you need to be able to see multiple different sides of your project if you're working in 3 dimensions. I mean, that more or less goes without saying. So you can either use the orbit tool down here and then click and drag in order to rotate around, or, and this depends on personal preference, I personally find this easier, you can actually just click and drag the cube in the upper right hand corner, and you'll notice that the cube is labeled with top and front and right and left and all that kind of stuff. Back, all basically it lets you orient yourself to the relative facing of the object, of course assuming that you keep the relative facing of the object in line with this. Like, you can build, when you think about it, you can build a model with any orientation or facing you so choose. In which case, this starts to become less useful because now you can't just be like, oh, this part up here is the top because the way I built this, now this is actually the front. It's strange, but you'll get more familiar with it. You can also notice that if you mouse over individual bits, they get highlighted, which means that you can click on it and it will automatically bring that to the front. So I clicked on the far corner and it automatically reoriented everything so that it was back at the front. I can click on a plane, or a face rather, in order to look directly on that face. I can also click the home button back here and it reorients me to a 3/4 view, a more traditional 3/4 view that tends to be used a lot for 3D projection and stuff like that on computers. Now you'll notice that I've also got a grid down here. Now the grid is in whatever set of units you have it set to. In this case, it's going to be millimeters, but we're actually going to change that in a moment. But of course, this allows you at a glance to tell how large something is, or what it is relative to something else. But you've also got these colored lines. You got a red line, you got a blue line, and if I change the orientation, so I look at it front on, you've also got a green line. Those of you who have used math before, so pretty much everybody, may be able to make the connection between these and the different axes. So you've got the x-axis, the y-axis, and then vertically you've got the z-axis. Where these all meet is going to be the origin. It all sounds pretty familiar, right? I mean, that shouldn't be anything new. So that's a good way to orient yourself on the Fusion 360 plane, is to figure out where your axes are and figure out where the origin is. And that helps you to keep track of where you are and where everything is. Anyway, first things first, let's go ahead and change our units to inches, because that will be useful since we're going to be building this bookcase in inches. So if over here we've got the hierarchy, it's also known as the browser. This shows you all of the different parts of your model, sketches, bodies, faces, all that kind of stuff, construction bits, everything. So if you need to find something quick, chances are you can just check it out here on the browser and select it or manipulate it that way. So what I'm going to do is I'm going to mouse over this one that's got like a piece of paper with a ruler, and then there's going to be another icon that pops up. It's the same one except it's got a pencil added to it. That allows you to change the active units. So I'll hit that. Brings up a menu over here on the right hand side. Pretty much all the menus that come up are going to be on the furthest right hand side of the Fusion 360 window, which is a little weird, but at the same time it's pretty nice considering you at least have a consistent place to always look. So just change the value in the drop down menu to inch, hit OK, and you'll notice that the grid automatically resized itself. Cool. Handy. Nice. So with that in mind, those are pretty much the basics that you need to know in order to get familiar with kind of navigating the Fusion 360 interface. All this other stuff we're going to get more familiar with as we start building things. So you don't necessarily need to know what's going on underneath all of these, because we'll get introduced to them gradually as we go through the different tools used in order to build this. But before we get started building, we're actually going to set up some user presets in Fusion 360 for this project specifically. That's going to make our lives a lot easier when we're building the project to spec. So what I want you to do is, you'll notice that for each of these buttons there's a little drop down menu underneath it. I want you to go to the drop down menu for Create. No, I lied. What do I want you to do? I need to look it up. Actually, it's on the presentation. I just was skipping ahead. Oh, it's under Modify. It's under Modify. Sometimes they aren't exactly in where you expect them to be. Okay, so it's the drop-down menu under Modify. You're going to go to Change Parameters. And it brings up this pretty unimpressive empty window. You've got favorites, you've got user parameters, and you've got model parameters. Now, these favorites and model parameters will get automatically populated throughout use. However, user parameters you're going to fill in on your own. So we're going to go ahead and we're going to set up some user parameters. The way you do this is you click this green plus sign right here, and it should bring up another window. Look at that. Give it a name, give it a unit, enter an expression. You can give it a comment if you want to. We're actually going to skip giving any of these comments. That's useful for larger projects when you start having to reuse names and stuff like that, and you go like, oh, okay, this one is for the widget here at blah blah blah. It's so that we have the proper size for it, or whatever. There can be a use for it. In our case, though, many of the names are clear enough and the project is small enough that putting comments in isn't strictly a necessity. On the other hand, though, commenting things in general is a good idea as an engineer. So just keep that in mind for future projects. Anyway, for the first one, what's the first one going to be? So we're going to call it width. I'm using a capital W. You don't have to use a capital W. There's nothing requiring you to use a capital W. However, whenever you reference this width at any point later on in the project, if you use a capital W, you're going to have to use a capital W again. If you use a lowercase w, you're going to have to use a lowercase w again. The name has to be consistent across the project, including capitalization, otherwise the computer isn't going to know what you're talking about. So we're going to call it width, and I'm going to use a capital W. The unit should be inches, which is already there, useful. And the expression, so the expression is where you tend to fill in the actual value for this. The reason why they call it expression, you'll see in a moment. But for expression, we're just going to put in 32. So you should see down here under value, it should automatically populate with 32.00. If it does, excellent. You've already got width in there, you've already got units of inches, and you've already got expression of 32. You can just go ahead and hit OK. And as you'll see, now we've got it here. User parameter, width, inches, 32 inches, value 32. We can get rid of it with an X, although we're not, by clicking the X, although we're not going to do that. We're actually going to add a few more user parameters. So what I want you to do is, based on that, we're going to actually enter in a decent amount of user parameters. I'm going to show you one more, two more, and then I'll go ahead and challenge you guys to fill in the rest of these. Not really much of a challenge, but you know, something to do. Anyway, for the second one, we're going to call it ply, just P-L-Y. And I'm actually going to use a lowercase p, just to show you guys that it's interchangeable, and also it'll be easier to type since we're going to be using that a decent amount. And the value is going to be 0.725. So it's going to be called ply, P-L-Y. Units are in inches, and the expression is 0.725, which seems like a pretty specific amount, but that actually tends to line up with the thickness of a lot of, you know, plywood, like heavier duty plywood and things like that. So, and sheets of wood and stuff like that. So 0.725 is, in that sense, a totally valid. It's 5/8? No, it's even less than that. Or it's the fraction is, its denominator of the fraction is larger than that. It's 75 is 3/4, 12.5, 6.25, 3.75. 0.125. Anyway, it's close to 3/4 of an inch, regardless. Math in my head is failing me right now. So anyway, ply inches 0.725. Now the reason I put it ply right now is because I want to show you one of the other things you can do with expression. So let's add in a new value, and we're going to call it BlindTab. BlindTab. Lowercase b, but a capital T. So B-L-I-N-D, capital T-A-B, all one word. It has to be all one word. And that's the reason why I'm using the capital T here, so you can more easily tell that they're two words. So far so good, right? BlindTab, it's a name. We're already well familiar with names. I don't need to explain names to you. However, in this expression field, now this is the reason why it's called expression instead of value. We could put in like 0.3126587 or whatever, and you know, let it figure out its deal from there. Or what's this? Okay. Or we can put in a mathematical expression. In this case, ply times 0.6. And then as you see, value automatically populates with a number, 0.435. So apply times 0.6. Now, why might this be useful? Well, let's say, we're using BlindTab down the line, and we're like, oh, okay, cool. So we've built the project like halfway, and then we go, wait, the ply of the wood that we're going to be using is different. It's actually going to be thicker ply. Huh. Normally, that involves, and by the way, that kind of situation will happen a lot, not just in engineering, but in everywhere, but especially in engineering, where the constraints of the project or the materials you're working with will suddenly change. Now, normally, if you put all these values in hard-coded, you would have to go back and change all of them and everything like that. In this case, though, if we change the value of ply, we go, oh, okay, it's actually a full inch in thickness now. We can just change ply to 1. Because this one is dependent upon ply, it will automatically resize itself once we change ply. So we change ply to 1, and then BlindTab will automatically become 0.6, which is pretty useful, I think. I think it's pretty cool. So, cool. Once that's done, hit OK, and look at that under expression, it'll say ply times 0.6, and the reason it's OK is because I used all lowercase letters like I did with ply, and then it'll fill in with a numerical value here. So with that in mind, let's go ahead and have you guys enter in all of these other values once it actually loads. Eventually. Extra challenge, fill in these values while you can't see them. Hello? Seems clear to me that Google Slides doesn't like me right now. Okay, let me go ahead and make this larger. And then I'll move this to the background. There you go. Can you guys read that? Raise your hand if you cannot. Okay, so far so good. So yeah, go ahead and enter those in, and then raise your hand once you've entered them all in. Cool. Got one hand already. Got a really fast typist. Or at least somebody who's familiar with the I was going somewhere with that in my head, but I totally forgot it. That's okay. Lost the plot. It happens sometimes. Second hand, up. Third hand. Yeah. Fourth. Fifth. Now, to be perfectly frank, um, out of these preset values, for most of the build, at least, you're going to be using width, height, depth, ply, and kick. Uh, Later on, you'll start to use tab, and then eventually the other ones will sort of come into play. But you know, if you just get those done right now, that's okay too. Not a huge deal. I say that after pretty much everybody's done, but whatever. It's good to have all of them anyway. Alright, I'll give you guys about another minute to put these in, and then we'll move on. Alright, hand number 6. At least I think I saw it. Flashed up for a moment. And I'll tell you guys right now, Fusion 360 is a little bit weird to get used to, but it's actually got a lot of powerful tools to it, and hopefully that will be made pretty apparent as we're going through this. And, you know, maybe it'll motivate you guys to make something that you can use in, like, everyday life. Like, I've seen a few pretty cool things. Like, somebody made a computer that was also a desk. And so basically, they modeled the entire desk, and then they modeled a plexiglass with vents in it, kind of clear top to the desk that they could flip up, and all of the different components were mounted inside of it. So as opposed to a traditional computer, where you know the motherboard is mounted to the case and then everything's basically stuck to the motherboard or stuck to one of the carriages on the side or something like that. You know, there was a mount over here for the power supply, and then the power supply was plugged into the hard drive, which is mounted over here, and then a disk drive over on the side, which, you know, they only put in as a formality at this point. And then the motherboard was right up against, like, the front of the desk, so there were a bunch of peripheral slots on it and stuff. And then there was, you know, the graphics card hooked up to the motherboard, and obviously the USB and all that, or USB, the CPU. I know computers. Hooked up to it and all that kind of stuff. It was actually a very neat thing, and then they lined it with LEDs that lit it up different colors that would cycle and things like that. And they built that initially in a CAD program, like SketchUp or Fusion 360. So, okay, I rambled on long enough. Let's go ahead and return this back to its former state. Perfect. So now we've done that. That's pretty much all the prep work we need to do in order to get our sketch started. So now what we're going to do is I'm actually going to finish the stuff because I was so wrapped up in making sure you guys had that stuff down that I didn't actually do my due diligence. Whoops. 575. I'm sorry, this must be so boring. Zero 0.62? Yep, 0.62. Okay, now that I'm done and I'm caught up with you guys, let's start our sketch. So the way we're going to do that is we are going to go over here into our little sketch drop-down menu, and then we're going to select mouse over rectangle, which is going to bring up another submenu, and then we're going to select two-point rectangle. Now you should see these three sort of distorted squares. This allows us to start on a specific plane, so we can either start on the top, so we're going to be looking from the top down, or the front, so we're looking from the front on, so directly at it, or from the, well, kind of, yeah, from the right. So we're going to set it up so this is actually going to be the left side of the model, but we're looking at it from the right towards the left. So what we're going to do is we're going to do a side profile of our bookshelf, which means we're going to use the right plane. So just go ahead and select that one on the left. It's kind of confusing when they're flipped around like that. But anyway, go ahead and click on the right one, and then it should go zoom, and then zoom over to the side like this. It's pretty neato. So now we're looking at our grid from the side. As you can see, we got our z-axis and we got our y-axis here. Go ahead and draw a rectangle. Do not worry about the dimensions of the rectangle. Just draw one. So yeah, I just didn't even think about it. I just went click, click, and made a rectangle. Why does it not matter, you might ask? And if you did ask that, I would go, that's an excellent question. I'm actually just about to show you. What tab? Oh yeah, it's just under Sketch, Rectangle, two-point rectangle. And then that should bring you to the rectangle drawing tool. And then make sure to select the right plane when you do it, which is on the left side. It's weird. The one that's not front or top. And you can check the little cube over here to make sure that you're looking at the right thing. If you click on it and now it says right, then excellent. You are in the, well, right place. So, you know, like I said, arbitrarily sized rectangle. Why is that okay? Well, I touched on it on Monday when I was introducing you guys to Fusion 360, but I'll go over it again here. That's because everything needs to be tightly constrained in Fusion 360. That is to say, we need to set a dimension for pretty much everything to ensure that it's of the proper size, of the proper scale, and everything fits together nicely, because this is meant to be an engineering grade CAD program. So, with that in mind, under Sketch, go ahead and select Sketch Dimension. Just click it, and now you should get a little couple of vertical bars with a two-headed arrow next to your cursor. And if I mouse over any of these things, like if I mouse over any of these lines, you'll notice that they get highlighted. So far, so good. Let's select this front line here and click once. Now we can move the cursor, and you notice that there's this little, similar kind of deal. It's two bars, except this time they're horizontal, with a double-headed arrow. And there's a number on it, 1.9 in my case. Yours is probably going to be something else. This is telling us the size of it. However, we're going to do one more thing. Pull it out like an appropriate distance. Like, that's fine. You could do it even closer. And then click one more time. Now that 1.9, in my case, turns into a text box. We can put in whatever value here. We could put in like 1,000,000 inches if we wanted to. And then this rectangle would resize itself so that this side, and then by extension this side, will be 1,000,000 inches long. However, we're going to leverage the user presets we just created. So instead of typing in a numerical value, I'm going to type in height. And you can see where the capitalization becomes important here. See, I used the capital H when I created my user preset. If I use a lowercase h, the text turns red and it goes, I don't know what you're talking about. And you gotta go, no, I meant height. And it goes, oh, height, okay. And then it turns black and everything's okay. So I'm gonna hit height, or type in height, and then I'm gonna hit enter. And look at that. It automatically resized itself to something way larger than I was initially using. I made a tiny little rectangle, and it was actually far too small for our bookcase. It would be a bookcase for ants. I mean, really. So now that it's properly resized as far as height is concerned, as you might imagine, we're going to do the same thing with the top. So go ahead and click once on the top, drag it out a little bit, click again. This one is going to be depth. So we're using height and depth right now. And the reason we're using depth is because we're looking at it from the side, right? If we were looking at it front on, we would be using width. But because we're looking at it from the side, we're going to be using depth. So height and depth, it'll resize itself again. And would you look at that? We got ourselves the outline of a bookcase, but we're not done yet. No, sir, we're certainly not done yet. So hit escape once you've dimensioned both of those, and now you should have two dimensions here, one that's labeled one that's labeled FX26 and one that's labeled FX14. So we know that this is 26 inches and then this one is 14 inches. The reason it's FX is because it's a function, the result of a function. Anyway, that's something you don't really need to worry about too much unless you go into the more abstract and esoteric side of CAD modeling, which requires you to enter in equations in order to draw 3D models on the screen, which can be a lot more powerful, but man. Anyway, we've got the side of our bookcase. This is roughly how large it's going to be. Obviously, it's not to scale, since my computer screen is not nearly large enough to render 26 inches looking like that. And I'm taking a reasonable assumption here and saying that your guys' probably aren't either. But anyway, at least we have some sense. So now that we've done that, what do we do next? So we've drawn a rectangle. Boom, boom. We're going to draw 3 more rectangles directly onto it. So again, sketch, rectangle, 2-point rectangle. We're going to draw one directly on the top, one somewhere around the middle, and one is it? No, it's not directly on the bottom. One almost at the bottom. So as you can see now, I've got 3 more rectangles. I've got one where it's right at the top, one kind of in the middle, and one near the bottom. Again, the spacing doesn't really matter. You just got to make sure that they're sort of kind of in this general vicinity area, sort of. And on top of that, they need to be touching the front and the back of your initial bookcase rectangle. So they need to have the same depth as your bookcase rectangle. Once you've done those 3 rectangles, we're going to do 2 more rectangles, except this time they're going to be vertical. We're going to do one right at the back that runs from the top to the bottom, and we're going to do one kind of nearish the front. So once that's all said and done, yours should look something like this. Obviously with different proportions, because right now we're not worrying about the proportions until we dimension everything. But you should have 3, well, initially 3 horizontal rectangles and then 2 vertical rectangles. Now you'll also notice that because these rectangles intersect, what Fusion has done has automatically turned them into separate rectangles. So now we've got a whole bunch of them, as opposed to just, 5 more that were initially there. There's now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more rectangles. So now we got 10 more rectangles, just because they all got cut up like that. Now these are going to function as the sort of the outside and back of the bookshelf, the shelves, and the little kick plate in front, which will, be useful so that things don't get caught underneath. And yeah, definitely. Creating the rectangles, yeah, let me just go back a few steps. You're talking about after you create the initial one, right? Am I correct in saying that? Okay, cool, yeah. Just want to make sure. Yeah, so sketch, rectangle, 2-point rectangle, and then just, you got to make sure that they run from front to back. The horizontal ones run from front to back. So put one right at the top, one somewhere inside the middle. It doesn't have to be exactly middle, don't worry about it. And then one near the bottom. And the only one that needs to be, like, in a specific location is the top one. It needs to be at the top. The other ones, you can just kind of eyeball it. And then, once you've done your horizontal rectangles, you're going to do 2 vertical rectangles. One that's on the back, running from top to bottom, and then one that runs from the bottom of the bottom horizontal rectangle to the bottom of the bookshelf. So after all is said and done, it should look something like this. How do you delete rectangles? I've just been using undo, which is Control-Z. Control-Z is your best friend. That's usually a lot easier than having to go through and delete them, because sometimes you have to, like, delete, not only, you can't, like, just delete this one, you have to delete the lines in here too, and it just kind of turns into a pain. So if you hit Control-Z, it will undo the last thing you've done, and you can chain those together so that you can undo multiple things. So let me know once you've got all those rectangles up and running on your guys' models, your sketches. With a show of hands. Cool. Excellent. Just about everybody. So, okay, let's start dimensioning these real quick before we call it a day. So, sketch, and then sketch dimension, just like before. But now things are getting a little wonky, so follow along closely, just to make sure that we're all on the same page here. Let me just make sure I'm doing everything right. Yeah, okay. So I'm going to zoom in on this top one right here, so I can show you guys better what I'm looking to do. What I'm going to do is I'm going to click on the bottom line of the top rectangle, and then the top of our bookcase, so now both of them are selected. As you can see, it might be a little bit difficult to see because I don't know how good the bitrate is coming on your guys' end. But now I've got that double-headed arrow, except it's running between these 2 lines right here. And I can drag it out, and there we go. Now I've got a measurement that is the distance between these 2 lines. And I'm going to set that one to ply. And now, as you can see, the thickness of this top rectangle has been modified. What we're just going to do is we're going to do that with each of these rectangles we just made. So that one's also going to be ply. As you can see, we have a nice consistent top and back here. This one's also going to be ply. Bada bing, bada boom. This one's also going to be ply. And as you might imagine, oops, this one is also going to be ply. So zoomed out, you should see that the rectangles that we generated are now appreciably thinner. Well, at least on my end. Stop sketch. Which one, for the rectangles or for sketch dimension? Or, oh, you mean in general. Okay, yeah, you can just go back up to... You can just... You can just undo it. Undoing it is fine. Control Z, you're right back to where you were. Yeah, no problem. So now that we've got the thicknesses dimensioned, and they're all ply to make things easier, let's see if we can squeeze this in real quick before the end of the class. I'm going to go ahead and dimension... Whoops. I'm going to hit sketch dimension, not stop sketch. This line right here, what we're doing is we're going to dimension this particular rectangle out fully. And that's going to be with kick. Now, mine just happened to already be 2 inches, so nothing got resized. But yours might be resized, which means that this one gets pushed up or pushed down, and everything sort of moves to accommodate, which is fine. That's excellent right now. That's one of the powerful things about Fusion, is it will resize everything automatically in order to make sure that everything fits within the constraints that you're asking for. So I told us so far, okay, the overall shape and the overall size of this thing is going to be 26 by 14. The height of this bottom rectangle is going to be 2. The thickness of all of these inside rectangles is going to be 0.725. Figure it out. And it will. And we're actually going to go a little bit further than that. We're going to dimension this space in here. So let me zoom in again. The top of this bottom horizontal rectangle and the bottom of the middle horizontal rectangle, I know that sounds weird, but it might make sense in a moment. We're going to sketch the distance between those two with shelf. Hit enter, and it automatically opened up a little bit. Let me just make sure. Yeah, and then one more. I think we can squeeze one more in there. So last one, we're going to sketch or dimension the distance between the front of the kick plate and the front of the bookcase, and that's going to be a distance of just 1 inch. It's going to be one of the few times that we actually use a hard-coded number in here. Hard-coded, that's the computer scientist in me coming up. So boom. Now that we've done that, we've actually fully sketched out the cross-section of the bookcase from the side. Just make sure. Yep. Yep. So this is what the bookcase would look like if we were looking at it from the side. Obviously, we're going to need to bring it into 3 dimensions, but so far so good. And that should actually do it for today. We're out of time. So I'm going to ask the poll questions. And then, of course, I will keep it open for questions afterwards. So you guys are more than welcome to, if you want me to go over something again, just let me know. I'll be happy to do it. Just so we're all on the same page. I just wanted to get at least the sketch done today so that, we could start making it three-dimensional for next time around.